Hello guys. Today I'm going to start a new module which is binary tree. So what is a binary tree? So binary tree is a data structure which contains 0, 1 or 2 children. Okay. So suppose this is our tree contains some value. So this will also be a binary tree. This will also be a binary tree. This will also be a binary tree. So it can contain at max 2 children and it can contain minimum 0 children. Here we have 0 children, so these are the leaves, and it can contain 1 children as well. So this is also a binary tree. So this node contain only 1 children, right? So this is the binary tree. Now, how the node structure of the binary tree looks like. So the node structure of the binary tree has 3 component. One is the data component, or we can say the value stored in the node. The other component is the left reference, the reference to the left node, and the other one is right reference, the reference to the right node. So suppose this is your node, so this will contain the data, it will contain the reference to the left node, and it will contain the reference to the right node. Okay. Okay. So let's move on. So first, we will understand the different type of traversal in binary tree. So, why do we even need the traversals? So, so if you consider binary tree as a data structure, so suppose this is our binary tree. So to explore all the nodes of this tree, we have to have a traversal mechanism, right? So So that's why we need the traversal mechanism, because by using this traversal mechanism, we will be able to explore all the nodes present in our data structure, right? If we don't have the traversal mechanism, we will not be able to explore all the nodes which are present in our data structure. So what are the different traversal mechanism in binary tree? We have two types. We can segregate it into two types. The first one is depth first traversal, and the second one is breadth first traversal. So what is depth first traversal? So, as the name suggests, in the depth first traversals, we first go into the depth of the data structure. So, here if you see in the depth first traversal, what we will do, we'll go to into the depth. Like we will first explore the depth of that data structure, right? So that's why it's called depth first. So first we'll explore the depth of the data structure, um, and uh, the other type of traversal mechanism is the breadth first data structure. So in that traversal mechanism, we will first explore the breadth of the structure rather than going into the depth. Okay. So when I will explain the types inside these traversals, you will get more idea why they are called the depth first and the breadth first. Okay. So we have three traversal mechanism in depth first traversal. The first one is pre-order, the other one is in order, and the third one is post order. And in breadth first we have level order. So let's understand them one by one. Okay. So what is the pre-order traversal? So the pre-order traversal is in which we first explore the root node, then we explore the left node, and then we explore the right node. So let's understand it with an example. So suppose this is our binary tree. Okay, so suppose this is our binary tree, and we want to write the pre-order traversal. We want to do the pre-order traversal on this. So as the name suggests, pre. So pre means first we will explore the node itself. Okay. So suppose we want to start from here. So first we will explore this node. So the value of this node is 1. Okay. Then we'll explore the left of this node. So the left of this node is this node. Then again on this node we will first explore this node. So the value of this node is 2. Then we will explore again the left node. So on the left node again we will explore the first we explore the this node. So the value of this node is 4. Now the left of this node is null, right? So we cannot proceed further. Okay. Then what we'll do, we will explore the right of this node. Okay. So the right of this node is also null, right? So we explored this node completely. We'll go back. For this node, we already explored the left portion. So we'll explore the right portion now. So the right portion, we have this node. So again, we will first explore the value of this node, which is 5. And then again, left of this node is null. So we cannot proceed further. Then we'll explore the right of this node, which is also null. So we already explored this null. Then we'll go back. Okay. Then this node is also completely explored because we explored the node, the left portion and the right portion. So we'll go back here. For one also we explored the left node. Now we'll go on the right side. So when we'll come here, so this node, for this node we again explore the value of this node first, which is 3, and the left of this node is again null. So we cannot proceed further. The right of this node is also null, right? So we explored this complete node. We'll go back, and just because we explored the left side and the right side for this node also, so this is our complete pre-order traversal. Okay, so now let's proceed further for the other traversals. Okay, so now let's understand the in-order traversal. Okay, so what in-order traversal suggests? It says first we explore the left node, then we explore the root node, and then we explore the right node. Okay, so let's explore the left node. So for this guy, the left node is this. Okay, and for this guy, the left node is this. Right. For this guy, the left node is null. So we'll stop here. After that, what it says, explore the root node. So root node value is 3. So we'll print 3. For this guy again, right node is not there. So we explored this complete node. We did the in-order traversal on this complete node. We'll go back. For this guy also, we explored the left part. So now we'll explore the root node. So value of the root node is 2. Then we'll explore the right part. So we'll go here into the right part. Then we'll explore this node. So for this node again, we have to explore its left, which is null. Then we'll explore this node. So this value is 4. Then we'll explore its right node. Value is null. So we explored this complete node. We'll go back here. Now we explored this complete node, right? This complete, we can say binary tree. So we'll go back. Now for this guy, we explored the complete left part. So we'll explore its root node value, which is 1. Then we go back and here and explore the right part. So on the right part, we have only 5. So we'll try to explore the left of the 5, which is null. Then we'll explore the value of the 5, which is 5. We will again explore the right value, which is again null. So this node is completely explored. We'll go back, and as the left and the right and the value of this complete node is also explored, so this complete tree is explored. So this is our in-order traversal for this complete tree. Okay, so now let's move forward and see the post-order traversal. So what does post-order traversal says? First we'll explore the left node, then we'll explore the right node, and then we'll explore the root node. So as the name post suggests, that means we'll explore the root, the value of the node later, like post. After exploring everything, we will explore the root of the node. Okay, so let's draw one binary tree here. So into the post order traversal, what we have to do, first we have to explore the left node, then we have to explore the right node, and then we have to explore the value of the node. Let me change the pointer. Okay, so let's write the posterior traversal for this tree. So first we'll start from this node. So what we have to do, we have to explore the left node. So left node is this, and on this node we have to explore its left node, which is this. For this node, the left node is null. Okay, so we cannot proceed further, so we'll go on to the right node of this one, which is again null. So we'll print the value of this node, which is 3, right? So we explore the left, then the right, then the value. So we explored this node completely, so we'll go back on 2. For 2, we have explored the left side, so we'll explore the right side now. So on the right side, on this node, we'll explore this node left side, which is null. Then we'll explore the right side, which is again null. So we'll print the value of this one, which is 4. Now we have explored this complete node. So we'll go back. For 2, we have explored the left side and the right side both. So we'll print the value of this node, just 2. Then we'll go back here. For 1, we have explored now complete left side. So we'll go into the right side. So for 5, the left node is again null, right node is again null. So we'll print the value of node, which is 5. So now we have explored this complete node. We'll go back here, and for 1 we have explored the left side and the right side both. So we'll print the value of the node, which is 1. So this is our post order traversal. Okay, so now let's understand the level order traversal. So this is the part of the breadth first traversal. So let's write or take the same example here again. Okay, so why it's called the best first traversal? So if you see the previous example in all the traversal, what we did first, we went into the depth of the tree, and then we started exploring. So we were actually exploring first the depth of the tree. We were going into the depth of the tree in all the previous examples. We were exploring the depth. Here also we were first exploring the depth, right? So that's why it's called depth first. Now in this case, what we will do, we will first explore the breadth. So we will first explore the nodes present on the breadth. So we will explore the breadth rather than going into the depth. Okay, so now let's just clear this off. So first we need to understand the level. So level in the tree are being represented like the root is present on the level 0. Some people say on the level 0, some say on the 1. So suppose we are saying on the level 1. Then its children will be present on the next level, which is level 2, and their children will be present on the third level. So likewise, our level will keep on increasing. So what the level order traversal say, explore all the nodes present on each level. So first we'll explore the node present on the first level, which is 1. Then we'll explore the nodes present on the second level, which is 2 and 5. And then we'll explore the nodes which are present on the third level, which is 3 and 4. So this is our level order traversal. So if you see here, we are first exploring the depth we are first exploring the breadth rather than going into the depth. So that's why it's the part of the depth order traversal. Okay, so now let's proceed and write the code for all the traversal that we have discussed so far. We have the other different traversals also, or you can say the traversal in which we print the tree in a different manner. So here also we are printing the elements of the tree. So we have different traversal in which we print the apart from these traversal, we have different traversal in which we print the elements of the tree, like diagonal view or the top view, or the right view or the left view. So we will discuss those into our coming for the lecture. So right now we'll go ahead and write the code for all these four traversals that we have discussed so far. Okay, so let's create one more project here. And I have put all the code that we wrote in the recursion on the GitHub also, so you can access the code from there also. I have updated the links in the videos of recursion. Okay, so now let's create a new project, say binary tree. Cool. So now we have one more project, binary tree. So let's go ahead and add one class, say tree node. Okay, so as we discussed, the tree node have three data. First is the data of the node. The second is left reference, and the third one is the right reference. Okay, let's put one constructor as well. So this will constructor, let's hope it's accept the integer, and let's initialize our data by using it. So this is our tree node structure. That's great. Now let's create one more class, and we'll name it as Traversal util. So this class will contain all the traversal for the tree. Okay. Okay. So let's start writing the traversal. So first we'll write the traversal pre-order traversal. Okay. So and just because, let's make this class static as well, because it's a util, right? So we don't even need to create the instance of this util. So let's write our pre-order traversal. Okay, and what we'll accept, we'll have the root node. Cool. So first we'll check if our root node is null. If our root node is null, that means we don't have anything to traverse. So we'll just return from here. We'll print nothing. Okay, if our root node is not null, then what we'll do, we will first, so in pre-order traversal, let me go back here. This is the pre-order traversal, right? So first we will printing the value of the node, then we will exploring the left, and we will exploring the right. That's what we did here, right? So let's write the same in the code. So let's print the value of the node. We'll print the value of the node. So value of the node is root dot data. Let's put comma and space also. Okay, now what we'll do, we'll explore the left. So let's explore the left side, and then we'll explore the right side. So this is our pre-order traversal. Now again, let's go back to our example. So if you see here, what we are doing, we'll start from here. Let me put it like this. Uh, let's remove this part so at least we'll be able to see what we are doing. Okay, and let's move this little bit here. Okay, so what we are doing, we are starting from here, right? So this is our route. So we are printing the value of the route, so which is 1. Then we are going into the left, right? We are calling then this part. So we'll go here, we are passing the left node. So we'll come here, our left node will come here. Then we will do, we'll print the value of the left node, right? So this is what exactly we are doing here, right? If you don't understand this, let's just go back into my recursion series, and you will be able to understand how this recursion is working. Just create one stack trace and go through it, or um, maybe at the end of the video I will create one stack trace and let you know like how this thing is working. Okay, so let's run this program. Okay, so what we have to do first, we need to create a tree. So let's create one tree node. So let's pass the value as 1. Then what we'll do, on the left we'll assign one more node. Suppose its value is 2. On the right side we'll assign one more node. Its value is, so let's see here what kind of tree we have. So the root left is 2 and the right is 3. So we'll make right as 3. Now root left has, well, root left has value 4. So let's assign 4 to this guy. And then root left right has the value 5, right? Let's go back and check it. Yeah, root left right has the value 5. Okay, so let's go ahead and print the value. Let's go ahead and print the traversal. So this is our traversal util, call preorder traversal, pass the root, and let's run the program. Change it to binary tree. Let's run the program and see what will happen. Okay, so we have to stop the console window as well. So let's put read line to stop the console window. Now let's run it again. Cool. So 1 2 4 5 3. Let's go back what we printed here. 1 2 4 5 3. Okay, so our pre-order traversal works. Cool. Now let's go here in traversal util and write the Inorder Traversal. So again we'll check first if root node is null. If root node is null, we don't have anything to traverse, right? So just say return. Else what we have to do in Inorder Traversal, let's go back to our Inorder Traversal. Okay, so this is our Inorder Traversal. So Inorder Traversal, first we explore the left, then we print the value of the node, and then we explore the right. Okay, so let's explore the left first. Left, then we print the value of the node. So let's print the value of the node. Now explore the well right portion. Okay, so now let's go back and check if this thing also works. Let's see what example we take in Inorder Traversal. So in Inorder Traversal, what we did, okay, so we took the different example. Okay, so let's change this example to our Inorder Traversal example. So here we have 5, 3, and 4. Cool. Now let's make it to root 1. Okay, so now call again our traversal util, and this time we'll call the Inorder Traversal. Let's pass our root 1 here, and let's insert one new line as well. Oh, something bad happened here. So what happened? Okay, so we have to change all this to root 1. Cool. Now let's again. Okay, so let's go back to our let's go back here. So yeah, our Inorder Traversal also looks same. Cool. So now let's go back and write the code for the post-order traversal as well. Stop debugging. Go back to our traversal util again. Let's write the code for the post-order traversal as well. Okay. Again, if root is null, we cannot do anything. So just say return else we will. So in post-order traversal, what we used to do, first we explore the left node, then we explore the right node, and then we print the value, right? So let's first explore the left node, then explore the right node, and then print the value of the node. So value of the node is root dot data. Let's put one comma and space. Okay, so now let's run this one also. So let's see what tree we took in this case. So in this case we took the same tree as we took in the Inorder Traversal example, right? So that's quite easy. So let's put one more console new line here to get the output on the new line, and then just call the traversal util and call post order traversal and pass root 1. Cool. Now let's run this. Cool. So let's check this output with the output we had. So 3 4 2 5 1, which is same. Okay, so looks like our pre in order and the post order traversal works. Okay, so now let's see how this recursion is working. So let's take the example of our pre-order traversal and see how this recursion is working. So let me stop the program and let me go into this function. Cool. So this is our pre-order traversal. Let's put it this side, and yeah, this is our pre-order traversal. So now let's see how this thing is actually working. Cool. So let's draw one stack here. This is our recursion stack. So initially we are starting from the root, and then we are printing the value of the root. So let's say this is output. So first we will print root dot data. So root dot data is 1. So this is fine. Then we are saying we are calling the function from here, right? So we are calling the function from here, and we are passing the root left, right? So we are passing 2 as node here in this, right? So after coming here, what we'll do? Uh, so again we came into the same function, this function, and our root this time is 2, right? So our root this time is 2. 2 dot data will be again 2. Then we'll go to the left of the 2. So again we'll go here. Now this time our root is left of the 2, which is 4. Okay, it's 4. So 4 node data is 4. We'll and then we'll try to go to the left. So we'll come here, and the left of the 4 is null, right? So when we'll come into this function call, you see here root, if root equals to null, we are just returning, right? So we'll come here, we'll return. So when we'll return, we will return from this function. This function will return, right? So after this function, what is the function called next? We are saying go to the root right. And what was the root? What was the root in this case? The root was 4, right? So what we'll do, we'll again make another function call, okay, and this stack trace will be destroyed when we'll come back from here. This stack trace will be destroyed. So we'll here now we'll make the function call for the right, and 4 ka right is again also null, right? So we'll go here, and this is again null. So we'll again come here at this part, and we'll return, right? So this part is all, this stack trace will be destroyed then, and then we'll come here again at this point after returning, and after this function call there is nothing, right? So we'll again return, right? So this stack trace will again be destroyed. hmm? This stack trace is destroyed. Then we'll come here, right? And then we come here. Then what so we will come here. So we'll fall from this left part, right? So we'll go into the right part. So we'll say, okay, what is the right note of the 2, which is 5. So we will make a controller for the 5, right? And then we'll print the data of this thing, because we'll come here. So it will be 5, right? Then we'll go into the left node of the 5, which is again null, right? So we'll make a call which is null, and then just because of this instruction we'll return. So we'll return again here. So we'll fall from this part, we'll go into this. This is saying make a function call and pass the right node of the 5, which is again null. So we'll again return from here. So this complete thing will return, right? Mhm. Now this function will also return. So there is no function call after this, so this function will also return. So 5 will also return. Okay, then we explore the left and the right of the 2. So 2 will also return, right? We made the both function calls for this. So 2 will also return. Here we made the function call from 1, right? So now if you see, the whole left part is explored for 1, right? Okay, so now this function call will return for 1. Okay, so we'll make the another function call and say pass the root which is on the right side of the 1, which is 3. So we'll make a call and pass 3 here, and then again for same thing for 3, we'll say okay, now we'll first print the data of 3, data of this node, which is 3. Then we'll see, we'll pass the left side of the 3, which is null. So we'll come here and we'll return, right? So it will go here, it will pass null, and then it will return. So left side will return So left side will return. Now we'll check for the right side. The right side of 3 is again null, so this will also return, right? So all the functions calls for 3 is ended, so this will also return. So 3 will also return. Hmm? So 3 will also return. Now for 1, we have explored the left and the right, right? So for 1 also, we will there is no function call after this, so this will also return, right? So this is our pre-order traversal. And the same thing we can same thing we can discuss for our in-order traversal as well. So you guys can go ahead and write the stack and do it for the in-order traversal. The only difference is we are printing the value after the uh, function is returning from the left portion. I hope you guys now understood how these three traversals are working. I will I will make one more video for writing the code of the level order traversal. If you haven't subscribed to my channel, go ahead and subscribe. Thank you for watching the video.